All right, so event A occurs with a probability of 0.355. Event B occurs with a probability of 0.2. Events E and B are mutually exclusive, and we want to answer all of these different questions. All right, so let's just start with our information. And since we have these down here that involve the complements, it's going to be smart for us to draw a diagram of this. So I'm going to draw a Venn diagram, and I'll draw a rectangle as best I can here. I know it's not great with just sort of using my mouse to draw. Okay, so I'm gonna, since they're mutually exclusive, A and B, the circles I draw for them will not overlap. So A and B, and I'll go ahead and try to label them as best they can. All right, now let's go back for a second. A had a probability of 0.355 and B had a probability of 0.2. So going back to my picture, this one is 0.3. Oh, well, that's wonderful. 355. Let's make a better point out front there. And then this one is hopefully a little easier to draw. 0.2 probability. Okay. Now, let's start answering the questions here. All right, so if I go back, now they don't overlap. That's what it means for them to be mutually exclusive. So the intersection is really 0 when they're mutually exclusive. So if we go back, our very first question is the probability of A intersect B is 0. Okay, now for part B, we want to find the union. Now, for the union, we've got a formula, and I don't know if I opened let me open a new Word file to answer this. Maybe. There it goes. All right, so the probability of A union B is equal to the probability of A plus the probability of B minus the probability of their intersection. So let's fill into the formula. The probability of A was 0.355. The probability of B was 0.2. And we already said that if they're mutually exclusive, the probability of the intersection is 0. So this ends up giving us 0.555. And let's here. Didn't tell us how to round them off, so we'll leave it at 0.55. All right, now the probability of A given B. So let's use our formula for conditional probability. So the probability of A given B is equal to the probability of the intersection over the probability of the second one in the notation, which is our B. Now we already said the probability of the intersection is 0, the probability of B is 0.2, and 0, of course, on the top of a fraction is always going to give us 0. So this probability is 0. All right, now, for our next one, that's why we need that Venn diagram that I drew, because we need the union of A with B complement, and it may be easier, rather than using the formula, to use our picture. Now, B complement, let's go back here to my picture. B complement is everything outside of B. So let me change my color on my pen. Everything outside of the circle B and I know this isn't straight or beautiful or anything since I'm drawing with my mouse, but it's all this stuff. And we know how to find a complement. We subtract B from 1, B's probability from 1 to get the complement. So this red area that I'm highlighting with lines is the complement. If we subtract 0.2 from 1, B complement is 0.8. Okay, but we want the union of A with B complement. Well, notice that A is actually part of B complement. So if we put them together, we're still going to get B complement. So that means that A union B complement is actually 0.8. It is the probability of B complement. All right, so this is 0.8. All right, now let's find the probability of A complement intersected with B complement. Let's draw A complement first. So going back to my picture, I'll use a different color. I'll use green. All right, and A complement will be everything outside of A. So I'm going to just make it green. Not straight or pretty, but that's okay. Well, that wasn't supposed to be an A, but I think if I try to erase it, it'll be a little bit. Okay, so there's our A complement. Now we want the intersection of A complement with B complement. Now recall a minute ago, B complement was the red, A complement is the green. Intersection means we want where they overlap. We want where they are together. So we're looking for where the red and the green are both together. So if we look at this, this is really everything but A and B. And we know the union of A and B was 0.555. So this is really the complement of that union. So 0.55 subtracted from 1 is going to give us all of this red and green on the outside. All right, so let me do that computation. So 1 minus 0.555 is going to give us what we're looking for in this last step. And that ends up being 0.445. And we can go back here and fill it in, 0.455. And we're good from there. And actually, I think this is yours, so I can't hit return and put it in there.